Alright, so we've been looking at what we call polygons and talking about how polygons are closed figures that are made up of line segments. And we talked about how polygons are named based off of the number of sides and angles they have. Like, for instance, this over here, this triangle, it has 3 angles and 3 sides. That's why it's called a triangle. Any polygon that has 3 angles and 3 sides would be called a triangle. And we go right down the line. A quadrilateral is a polygon that's made up of 4 angles and 4 sides. Pentagons are made up of 5 sides or 5 angles. We have a hexagon made up of 6 sides, 6 angles, and then octagon. These are the common ones again. You have the octagon, which is made up of 8 sides or 8 angles. And the figures that we see here are the typical polygons that we're used to seeing, but really they can look like anything you can imagine as long as they are made up of straight sides and are closed figures. We still name them based on the number of sides they have. For instance, see if I can try to draw this for you. If you had a one like this, okay, let me try to draw that a little bit better for you. For instance, here's one actually that we'll be actually looking at quite a bit. If you see this here, okay, you might think right off the bat, oh, that's a triangle, right? But it's not. It's actually a quadrilateral. It has 4 angles, and I'll circle those angles for you. You have 1, 2, here's another angle in here, 4. Okay, so that's actually a quadrilateral, and it actually has 4 sides. 1, 2, 3, 4. Okay, so again, we name these shapes, these polygons, based on the number of sides, and they all fit into the categories that we've talked about. But today we're going to focus on one category, and this is the category of quadrilaterals right here, which we've mentioned before. So all these polygons that we're going to be looking at today, they are all shapes that are made up of 4 sides. And as you can see, as you come down this tree here, there are different subcategories, different types of quadrilaterals, and they have specific characteristics that are unique to that type that make them a parallelogram or a trapezoid or a rectangle or a rhombus and a square. And we're going to go over those different unique characteristics throughout this lesson. It's important to notice that when you look at this tree, that you can see that these all fall under the same category of quadrilaterals, and these 3 shapes here all fall under the category of parallelograms. These are all parallelograms, but they have unique characteristics that make them different from each other. Okay, so let's take a look at quadrilaterals and what exactly are they? Well, the first thing we need to know is what makes up a quadrilateral, and we've already gone over this. They are polygons. They are made up of 4 sides, and they have 4 angles. It doesn't matter what they look like. If they have these 3 characteristics, they're polygons, have 4 sides, and have 4 angles, they are all quadrilaterals. Even if they fit into the subcategory of quadrilaterals, they still fit into the bigger category of quadrilaterals. So now let's take a closer look at each one of these subcategories. The 2 main subcategories of quadrilaterals are parallelograms and trapezoids. Let's first take a look at what a parallelogram is. Okay, a parallelogram has 2 sets. Sorry for my handwriting, it's kind of hard to do this on the iPad. But they have 2 sets of parallel lines. In other words, the opposite sides of a parallelogram are parallel. Okay? Look at these two lines here. These two lines, and then the opposite line of it, this line, they are parallel. That means if I continue on this line this way and in a perfect straight line, and if I continued on this way with this one, they would never cross. Remember when we talked about parallel lines? Going over lines and angles, parallel lines never cross. So in a parallelogram, they have two sets of lines that never cross. So there's two there. And then if you take a look at these green, we'll use green for the next ones. These two opposite sides right here never cross. If I kept going straight this way and straight this way, they would never cross. So a parallelogram has two sets of parallel lines that make up the shape. Or think of it, the opposite two sets of where the opposite sides are parallel. Here and here. Okay? Look at this other shape over here. Notice how these two lines here, they are not parallel. That if I kept going like this and I kept going like this, they would eventually cross over and intersect. Okay, so those two sides are not parallel. They only have one set of parallel lines. So therefore, it would not be a parallelogram. I'll tell you what that shape is in a little bit. But now let's look at the different types of parallelograms there are. There are three different types that we can look at. The first is a square. And the unique thing about a square is that it is a parallelogram, it is a quadrilateral that is made up of all 90-degree angles. That's like that perfect corner of like a door. If you remember going back and looking at the angles, it's that perfect corner. So every angle, every vertice in this shape, in this polygon, is going to be a right angle. It's going to be that 90-degree, that perfect straight up and straight over angle. Okay? The other thing that's very unique to a square is that all the sides are the same length. So this side, this side, this side, and this side are all the same length. So if I know the measurement of this bottom side here is 9, then all the sides are 9. If I'm told that this top measurement is 10, if it's a square, then all the sides measure 10. 10 inches, 10 centimeters, whatever it would be. So a square is a parallelogram because it has those two parallel sides, two sets of parallel sides, these ones here, these ones here, okay? But the unique thing about a square is that it's made up of all right angles and all the sides are the same length. Okay? Now the next one we have is a rectangle. Rectangle is very similar to a square in that it too is made up of all right angles. All of its vertices, angles, corners are what we call the right angles, that perfect, like corner of a book, corner of a door angle. The difference between a rectangle and a square is that with a square all the sides are the same measurement. With a rectangle they're not. The opposite sides have the same measurement. Okay, so these two green sides that are opposite would be the same measurement. But my purple sides are not. I mean, the purple sides are the same measurement as well. But the purple sides and the green sides, right here, they are not the same measurement. So for instance, if this top was 10, then I would know the bottom's 10. However, the left and the right side are going to be different measurements. And I would have to either measure to figure it out or just go by whatever measurement's given. Okay? So it's just like a square. It's made up of all 90-degree angles, but not all of its sides are the same measurement. And then we have what we call a rhombus. And this too is very similar to a square, but has one difference. Okay? Just like a square has the equal sides, where all the sides are the same measurement, this side here is the same as this side here, and this side, and this side. Okay? They are all the same measurement. If this side is 9, then they're all 9, just like a square. The difference has to do with the vertices and the corners. Remember, a square had all 90-degree right angle angles, okay? A rhombus doesn't. They have acute and obtuse angles. And so basically, you're going to learn more about obtuse and acute. I know you learned a little bit with me this year about them. But really, you got to just think of a rhombus as a square that is tilted or slanted, because the angles are not the perfect right angle. And if you look at it, you can tell that that rhombus looks a little slanted. So remember, two things about a rhombus. All the sides are equal, and it's a slanted square because it does not have 90-degree angles. Okay? And again, a square, a rectangle, and a rhombus are all parallelograms. They are all parallelograms, and they're all quadrilaterals. Now look at this shape here, okay? This shape looks sort of like a rectangle that's slanted a little bit. Alright? And if it does not share any characteristics with a rectangle, a rhombus, or a square, then we just simply call it a parallelogram. Opposite sides are parallel, okay, like so, but it does not have 90-degree angles, and not all of the sides are the measure the same length, so it's not a square, it's not a rhombus, it's not a rectangle, it's just simply a parallelogram. Then we have the second subcategory of quadrilaterals, and this is what we call a trapezoid. Okay, here's a trapezoid. And that's a quadrilateral that only has one set of parallel sides, or one pair. Remember, a parallelogram had two. It had two sets of parallel sides. A trapezoid has only one pair of parallel sides. If you look at this trapezoid, these two sides here are parallel. If I kept going in opposite directions with these two lines, they would never intersect. However, when you look at these two lines, this line here and this line here, they are not parallel. If they kept going up like this, they would eventually intersect, right? Okay? So it has one set of parallel sides, which makes it a trapezoid. Take a look at some more of these trapezoids that we have. Here's another version over here. We have this side and this side that would eventually cross over if it kept going. Same thing here. These sides on this side would keep going. So trapezoids can look all different. Notice how these shapes look different, but they're all made up of only one set of parallel lines, so they are all considered trapezoids. That's what we would consider them. And then finally, let's look at that figure that I drew at the beginning of our lesson that kind of looked like this, almost like a triangle. Or if you ever watch Star Trek, then it looks kind of like the little Star Trek symbol. Again, remember, we said this was not a triangle because it had 1, 2, 3, 4 angles and 4 sides, right? It's still a quadrilateral. However, it does not fit into any of the other subcategories of quadrilateral, so we simply classify it as a quadrilateral and nothing else. We wouldn't say that